Virtually every utility has a library of component standards, and in many cases these standards are used on a daily basis for reference or to include with the package of design documents. Here are 3 ways that I've seen utilities use these standards. Case 1, basic standard viewing. In this implementation, the only goal was to be able to access the standard associated with a component by selecting a ribbon option, clicking on the component, and having a browser window open with the standard document. Case 2, create a standards PDF for the design package. In this case, the requirement was to create a single PDF document that contained each standard that was referenced in the design. Case 3, insert the PDFs for each standard into the drawing. In this implementation, the requirement was to access all of the relevant standards once the project was complete and to insert them into paperspace layouts, 10 per page. With each of these 3 cases, there were 3 things to consider. First, where are the standard documents stored and how are they named? Second, how should components in AUD reference the standard documents? And third, once you have 1 or more specs referenced in your design, what do you do with them? So I'm going to talk first about storing and naming your standards documents. Every utility I've worked with manages their standards within PDF documents, usually published as a small set of comprehensive books. For example, a book with underground design standards and another one with overhead design standards. These are usually kept as PDFs on a network drive within the utility. While it's theoretically possible to access individual pages within a PDF, in practical terms, every utility I've worked with then has their standards department generate a set of individual PDF files from the master document. So for the purpose of this video, I'm going to assume that somehow the PDF files are split up into documents, 1 document per standard. Now it's beyond the scope of this video to explain alternative methods to split up a PDF, but if the best you can get from your standards department is PDF books, Adobe Acrobat does make it easy to break up the books into individual pages, and there are tricks and techniques you can use to access information within each page to improve the file naming. The question of naming the individual standard files is critical. The file names must be stable because you can't refer to something if the name might change at some point in the future. This means you can't simply split up the source PDFs and assign them names started with 1 for the first page in the document and 2 for the second page and so forth. Whatever names are used, they will be needed to be linked to CUs or models in AUD, and this linkage has to be stable over time. Naming usually follows one of 2 approaches. I think the ideal approach is naming them by CU, possibly with some variations. This is ideal because you can tell what each document contains just from the name, and CUs don't change. But there will be some variations. For example, in some cases, several CUs will be displayed on a single page. This is common in specs, for example, for framing. The naming for such pages will have to be handled by some kind of exception. There are also cases where a single standard applies to a number of CUs. This is common with transformer standards. For example, the same standard may apply to all pad-mounted single-phase transformers regardless of their kVA rating. And finally, there are sometimes cases where there may be more than 1 spec for a given CU or model. In this case, you may need an approach to reference both specs. A second workable scheme is to name documents by section and page. Indeed, in some cases, a standards department may already produce individual documents that are named by the section and page within that section. This can be acceptable if the standards department has committed to keeping the page number constant for any given standard. So, for example, if a UK5 pedestal is described on page 602 in the Underground Standards Manual, it will always be found on that page in every future edition. Okay, finally I can get into some actual AUD configuration to handle the challenge of referencing the standards documents. I've used 2 methods in the past here. Approach 1 is to take each model and add a field within the feature class that provides a standards reference. Here's an example showing the riser feature class. There's a custom model attribute, that is an attribute with a value associated with each model in the feature class, called technical standard, or tech spec. And the name of the PDF file containing the standard is listed for each model. Approach 1 is really great if you set it up during the initial AUD configuration because it's easy using the SBS Smart Tools to add a field like TechSpec to every feature class. Once the field is in place, you can then use the Smart Tools to export all the models and all the feature classes to a spreadsheet, enter the reference information, and reload the model data into AUD. As you can see in this example, in cases where the same document covers more than one model, there's no reason you can't list a standard document more than once for every relevant model. If you already have a configuration in place, you might instead consider approach 2. In this case, I've added a table that maps CUs to standard documents. With this approach, you won't need to update your model tables, and it can easily be added to an existing configuration. And another thing to note about this table, it doesn't have to have one entry for every CU in your catalog. You only need to add the CUs that matter, the important CUs, those that are associated with the standards that you need to reference. Also note in this example that a description column has been included. This column contains the title of each standards document, and we'll use this shortly in one of the examples. Okay, once you have standards documents referenced by your components, let's get into some concrete examples of how you can use this information. The first case is basic viewing of a standards document. Here I am in AUD. If I select this switch, I can see in the specifications section that the technical standard is 6056-2000. So now I select the View Standard option on the ribbon, an option that I've added as a custom option. I'll select the switch, and the specification for that switch appears in a browser window. Great. This function can be programmed in Lisp. To make this possible requires 4 core steps. First, the user needs to be prompted to select an AUD object. Now, given the object, you have to get the AUD reference information for the object. Fortunately, it's pretty easy to get this information, the feature class and the FID, for any AUD object using Lisp. Now that I have the FID and the feature class, we need to perform a query to access the AUD object and get the file name for the technical standard. In this example, I'll be using approach 1, where the name of the document is stored in a field called TechStandard. Finally, you need to launch a browser or some kind of viewer to display the standards document. There's no out-of-the-box function in AUD to do any of this. It needs a little programming. Okay, I'm going to switch to VLisp, Visual Lisp, which comes with AutoCAD. Here's a copy of the function that I just used. Let's take a look at it and break it down. The first statement here sets the path for the files. In this case, I'm just storing them on a local folder on my C drive. Okay, step 1, prompt for the AUD object. This can be done using the ent_cell command, the entity select command. The command includes a prompt, and I'm going to store the result in the myEnt variable. Here, in Lisp, I'll select this statement and click on the load selection icon in VLisp to execute it. I'll flip back into AutoCAD. You can see the prompt came up. I'll select the switch. And now I'll flip back to VLisp, and on the console you can see the value of the entity handle that refers to that entity that represents the switch. Step 2 is where things get tricky. If the selected entity is an AUD component, it will have something called extended entity data associated with AUD that is part of the entity. I'm not going to try to explain the details of how this all works, but this line in Lisp will take the selected entity, stored in myEnt, and return the extended entity data associated with AUD, which it will store in the variable AUD data. Here, I'll select that line and I'll execute it. As you can see, there's a ton of information here. Then, this next line of Lisp will locate the extended entity data associated with AUD within the variable AUD data and extract just the feature class and the FID. So check it out. I'll select this next line and click on the load selection icon, and what's returned is a list that contains just the feature class EL switch and a 6-digit FID 221069. Now in step 3, I think this is the cool part. AUD includes a Lisp function called AUD query, and I can use it to access any data in the AUD underlying SQLite database. So I'm just going to demonstrate this first by typing a line here. Starting with an open parenthesis, I enter AUD query, and then in quotes, I put in the SQL statement, select text standard from EL switch, where FID equals 221069. Now I put in the quotes in an appropriate fashion. I follow it with a closed parenthesis. The Lisp command that we're going to use is AUD query, and then the SQL query itself follows in quotes. And look, when I execute this, the result is my text standard reference, 6056_2000. Now the actual Lisp here is a little more complicated, but that's because I have to start by creating the text string that represents the SQL query using this first statement. Then I can perform the actual query operation. We're almost done. One more step. Now that we've retrieved the file name, we just need to launch the browser to open the file. AutoCAD has a command browser, so this Lisp statement uses the Lisp command function to run the browser command, and the value passed to the browser command is a concatenation of the file path, the file name itself, and .pdf. So there you go. It's a starting point you can use to create your own function to access a technical standard. Of course, as with any programming, there's room for improvement. For example, what happens if there's no technical specification for a given item? You should, in that case, add an error message. Okay, now what if you need instead to assemble all of the standards documents that are used within a design project? I've seen this done in two ways. Some clients want a multi-page PDF that contains all of the project design standards associated with the project. Alternatively, some clients want to add layout sheets to their design document with several standards presented on each sheet. Both of these can be implemented using the same following approach. To begin, within AUD, we need to create a list of all the standards used in the design. In my sample implementation, I've done it as follows. First, I've used approach 2, so I have a custom table that maps CUs to standards documents. Note this table also includes descriptions for each PDF. Next, I've used the AUD material list configure command to add two custom material list columns, construction standard and construction standard description. Now, all we need is a rule in AUD that will take the CU for every entry in the material list, do a lookup in the custom table, and add the document and description information to the custom columns. This can be done with a single rule. If you look in the materials section of the rules, you can see the material items section. This is an unusual section because instead of working with feature classes, it is designed to work with the material list. Here's the rule that I created. This rule works as follows. If the status of the component is new, then set the attribute construction standard to be a table lookup within the construction standard map table that we just looked at. I want to find the row in the table associated with the current CU, so I filter the table on the CU column. Since each CU appears only once in the table, this will locate only one row in the table. I'll return the value found in the PDF name column, that is the reference to my PDF file. If nothing's found in the table, which will be the case for minor CUs and part numbers where there isn't a standard or where we don't care about the standard, the return value will be no PDF. And the second part of the rule is just like the first part, except it sets the value for construction standard description to the description column in the table. The result is two new columns now available in the material list shown here. Now that we have this information in the material list, we can turn to Lisp to create functions that display or export the standards used in the design. Let's first look at a Lisp program to generate a single PDF that contains all of the standards in this design. These first two statements are typical Lisp setup. In particular, VL load com is required if we're going to use any of the VLA functions within Lisp. This line here sets the path name for where the technical specs are located. In this case, they are in a local folder on the C drive. And this line defines the location of the output folder for the completed PDF that combines all of the standard PDFs. Next is the key part of the whole function. We perform a SQL query into AUD's material list using the AUD query function. I'm doing a select statement, selecting only one column, the construction standard, from the AUD material table. This is the table in AUD that holds the material list. The where clause ensures that I ignore any entries with no PDF in this column. And the key to this query is the group by clause in the SQL statement. Since each standard may be used more than once in the design, the group by clause groups them together by the value of construction standard so that each standard will only appear once in the list. Once we have the list, we should check to be sure it's not empty. If the list is 0, then we display an alert message. Otherwise, I'll continue. My strategy is to copy all of the specs selected into the output folder and then combine them. So first I need to erase any existing PDF files in the output folder with this statement. Now I use the Lisp for each statement to consider each entry in the list of file names. I'll use the VL file copy function to copy each standard in turn from the standards folder to the output folder. Now I have to combine all these files. There's no function in AutoCAD or in Lisp to combine PDF files. So in this case, I'm using a utility called PDFTK. I'm executing it using a DOS batch file. Here's the file. The command here in AutoLisp uses the AutoCAD shell command to execute the batch file in a DOS window. I pass two parameters to my batch file, the name of the output folder and the name of the combined file. And finally, I use the Lisp command start app to view the PDF. The first parameter is the app I'm going to run, in this case a utility called Sumatra PDF, which is a PDF third-party viewer. And the second parameter is the path and the name of the file I'm going to view. Here's the finished result. I select a ribbon option that runs my new Lisp function, and a PDF appears on the screen that contains each spec used in that design. Great. Now let's look at the second Lisp function that generates one or more layout sheets in the drawing with the standard PDFs inserted. Like the previous Lisp, I do some initial setup, starting by loading vi load com. But in addition, I get some drawing information, and in particular, I set a variable layouts that contains a list of the layouts that are currently in the drawing. Next, I'll set some constants. This includes the source path for the standards documents, but it also now includes some values we need later for positioning when inserting the technical standards into Paperspace. Now, exactly like the previous Lisp, I perform a query to get a list of all the construction standards files. This is exactly the same query used in the previous Lisp. And like the previous Lisp, I check to see if the length of the list returned is 0 and issue the same warning if there's no documents in the list. For the sake of this demo, I'm assuming that the technical standards are all placed on layout sheets named STDS followed by a number. So before the function begins, I'm going to delete all the existing sheets that start with STDS. These 6 lines include a VLAX version of the for each function to loop through all of the layouts found during the initial setup. Each loop looks at the left 4 characters of the layout name to see if it equals STDS, and if so, it deletes the layout. Next, I initialize 2 counters, one for the current document and one for the current layout sheet. Now I loop through the document list, just like I did in the previous version of Lisp. Now in my layouts, I can put 10 PDFs on each sheet. This if statement uses the rem function, the remainder function, with the document count and a value of 10. If the function returns 0, that means it's time to insert another sheet. If it is time to insert another sheet, I first increment the sheet count. Then I do several things to insert and update a new sheet. I do the actual insert using the VLA add function, with the sheet to be named STDS- followed by the sheet count number converted to a string. Then I use a VLA function to set the media name to legal because I want this to print on legal size paper. Next, I make the new layout the current sheet, and finally I select all the viewports found on that sheet, which I don't want but they get inserted automatically, and I erase them. Okay, now it's time for some math. This is where the document counter gets used. This first statement calculates the x-coordinate in paperspace units for inserting the PDF. Note this is based on the lower left point in paperspace that we plan to use, the document count, and the x spacing between different PDFs. The next statement calculates the y-coordinate. Then this statement creates the XYZ point for the insertion, which is basically by creating a list that includes the x and y coordinates and then 0 for the z. And this final part isn't math, but I determine the file name, given the file path we set earlier, and the name of the document with PDF glued on the end. Now the part we've all been waiting for. I use the AutoCAD PDF attach command to attach a PDF with the name file name. The page number of my PDF is 1. I'm inserting it at the point I just calculated, PT. I'm scaling it based on the constant I set at the beginning, PDF scale, and I'm rotating it 0 degrees. Easy peasy. Last but not least, I increment the document counter. The loop then continues through all the documents. Okay, let's watch the function in action. I'll begin by selecting it from the ribbon. And after a few moments, you can see that 2 new layout tabs have appeared here at the bottom. And you can see the contents of one of those tabs, and if I switch to the other tab, you can see the remainder of the inserted PDFs. This was a long video that covered a lot of ground, but the basic takeaway points are as follows. First, you need to decide where you're keeping the PDFs with your standards and how you name them. And you need a means of referencing the standards by linking components and/or CUs in your design to the PDF files. We covered 2 ways of doing it, one with reference to the model attributes and one that used a separate custom table in AUD as the reference. Then you probably need to create custom functions that leverage the reference information. This was done using AutoLisp in these examples, but you could also use AutoCAD's ARX program environment. The key to all the functions is the powerful AUD query function that gives you access to the information within the AUD SQL tables. This capability makes AUD an incredibly powerful tool because all of the data is accessible to do virtually anything you need, as you've seen with the examples of this video.